You have probably already seen videos on YouTube featuring titles like Zoom 1000 times of the moon or Close-up use of the moon 1000 times zoom, which are claiming to show the views of the moon magnified by 1000 times. All such videos, however, lie because this certainly doesn't look like a 1000 zoom of the moon. I took this picture of our natural satellite a few days ago, and the magnification was just 40 times. Some videos even caught Elon Musk performing his weird experiments in the moon's orbit. Therefore, the authors of all of these videos are simply lying or showing a fake. Such videos exploit a very popular misconception about telescopes and magnifications. Do you really want to know what the moon looks like with a 1000 times zoom? Well, here it is. Exactly. You'll see a blurry piece of crap without any details whatsoever. Contrary to what some may believe, using very high magnifications to observe celestial objects is usually a bad and unnecessary idea. Therefore, let's talk a little bit about the maximum magnification of telescopes. By this term, I mean a maximum zoom that will allow you to see a celestial object pretty clearly without making it too blurry. There is a formula that you can use to find the maximum magnification of the telescope. You just need to multiply the aperture, or the diameter of the telescope's tube, by 2. The limit of magnification is determined by various factors, such as the quality of your telescope and of course atmospheric conditions. If the atmosphere is very turbulent, then I'd even recommend multiplying the aperture by 1.5. If you go over the limit, the picture will look extremely blurry. Most of the telescopes have an aperture equal to 70, 90, and 150 millimeters, thus making the maximum practical magnification well below 1000 times. For example, here's the view through my telescope with an aperture of 60 millimeters and a 40 times magnification. If the picture is that blurry at such a low magnification, imagine what the moon will look like at a 1000 times zoom. Therefore, the main aspect of any telescope is not its magnification, but its aperture, which is basically the diameter of the main lens or mirror. The larger the aperture, the more light the telescope can collect, thus allowing higher magnifications to be achieved. Achieving extremely high magnifications is possible only by using very large telescopes, and only if the observing conditions are simply amazing. Theoretically, to get a clear image using magnification as high as 1000 times, you should get a telescope with an aperture of 500 millimeters, which costs a little bit more than you would expect. By the observing conditions, by the way, I mean things like the transparency of the air or the atmospheric turbulence. The atmosphere is the main enemy of good telescopic observations, since its layers are in constant motion, degrading the quality of the images. That's why the scientists send telescopes into space. There is simply no atmosphere that can make the image look blurry. Therefore, now you know that if a telescope manufacturer writes something like 660 times magnification on the box, well, that's theoretically achievable, but the resulting image will look something like this. By the way, the same rule applies to cameras. Even the most expensive cameras have magnifications that don't exceed 100 times. By magnification here, I mean the optical zoom, which can be achieved thanks to the camera's lens elements. You can, of course, also use the so-called digital zoom, which is achieved by basically cropping the image and then enlarging it to the size of the original picture. However, image details in this case are reduced, so even if you put the digital zoom at 1000 times, the image will once again look like this. Just kidding. In any case, it will look very blurry, so it's better not to use digital zoom whatsoever. Now, so that you know that a 1000 times magnification is not possible for most telescopes, you may be wondering what telescope you should get. And probably the best option for you would be to get a quality small or medium-sized telescope. Yes, you won't be able to see very small details of the lunar surface, but it's not necessary in most cases. The most beautiful views of the moon and celestial objects are usually achieved at fairly low magnifications. By using lower magnifications, you get a better sense of the moon's true scale, and appreciate that we have a chance to observe this gigantic world without any difficulties. The principle of utilizing lower magnifications also applies to other celestial objects like galaxies. Consider, for example, the Andromeda galaxy, which is, as seen from our planet, looks 6 times bigger than our natural satellite. Buying a quality small telescope is also a great idea, since if you happen not to like astronomy whatsoever, you won't regret that you spent thousands of dollars on a large telescope. If you're wondering which scope you should acquire, watch this video of mine. Link in the description. In any case, even at lower magnifications, you will be fascinated by the details of the lunar surface, such as intricate craters and seas. So let's put aside the misconception of extreme magnifications and embrace the wonders of the moon, which is actually just a hologram, because Earth is a cube.